Hello, welcome to another session on mathematics for data sciences. So, till now we have been looking at some discrete distributions, and here we'll be introducing two new concepts: expected value of a random variable and variance of a random variable. So, expected value of a random variable is like an average value of a random variable x. So by average value we mean if we keep picking any random values of this particular random variable based on the given probability distribution of this random variable, then let's say we pick 100 values from a particular distribution and we average them out, then the expected value of that average should be equal to this expected value. So basically, if we keep on increasing the sample size, eventually whatever average of those values we'll get, that should be equal to this particular expected value of the random variable. Now let us this is computed as expected value of x. It is represented as ex and it is computed as summation of x px. So now let us say we look at an example here. Let us say we have x and px here. Let us say x can take a value of 2, 5 and 10, and the corresponding probabilities are 0.2, 0.3 and 0.5. So we have to make sure the sum of the probabilities is 1, which is correct here. Now we calculate x px. So the sum, we are basically calculating the product of the value of x with the corresponding probability here. So 2 into 0.2, 0.4, this is 1.5, this is 5, so this is 6.9, and this is the required expected value for the random variable x here. Now what this value represent is, let us say we keep picking different values. So we perform, let's say, a simulation. Let us say for the simulation the trial is 1, 2, 3, 4, 5 and so on. So we are picking a lot of values of x based on the given probability distribution. So how we do that? Let us say we generate a random variable value u between 0 and 1. Now this particular value will be uniformly distributed in the range 0 to 1, and this will be continuously distributed. So now for the first trial, the first value of x which we'll get is based on, let us say we get u equal to 0.3 in this case. Now since the value of u is 0.3, we make a rule here that in case of x equal to 2, since the probability is 0.2, so if the value of u is from 0 to 0.2, we assign that value as x equal to 2. Now for the next one, it's 0.3, so 0.2 to 0.5 will be assigned the value of 5, and u greater than 0.5 and less than 1 will be assigned the value of 10. Now since for the first trial we have got a u value of 0.3, so let's write it here. So let us call this trial here 1, 2, 3, and we have got a u value of 3.3. So what will be the value of x? That will be 5. Similarly, let us say we get a u value of 0.7 here. Now since 0.7 is greater than 0.5, we'll get an x value of 10. Now let us say we get a u value of 0.05. Since this is less than 0.2, we get the x value of 2 here. So once we do that, we take a lot of these simulated values, and let us say we take 100 of these values. Then the average of these values of x which we have obtained, this value k, this is close to ex. So this ex which we calculated as 6.9. Also, as we keep on increasing the value the number of trials for simulation, the mean of x keeps coming closer to the required expected value. So for smaller sample sizes, it might not be uh, exactly equal to this 6.9 expected value, but it would be closer to 6.9. But as we keep on increasing the sample sizes, it will come closer and closer to 6.9. So this is how simulation works using a uniform distribution from 0 to 1. Now let us we'll be covering this expected value concept a lot in detail as well while we are going through the different distributions and deriving the expected value of different distributions. But for now, you need to understand that expected value is nothing but the average value of the random variable, and it is computed as the summation of the product of each value of x with their corresponding probabilities. And as we keep on sampling different values of x based on their probability distribution, we would eventually get an average of these simulated values being closer to the expected value of x. Now, variance of a random variable, as the name suggests, it is a measure of spread. So it gives an indication of how much spread is there in the random variable, and it is computed as, so we represented it as var of x, and this is computed as expected value of x square minus expected value of x whole square. So this expected value is same as what we just calculated, which is 6.9. So we are actually squaring it, but now we need to calculate the expected value of x square. So another thing to note here is the expected value of x is also called the first movement of random variable x. Similarly, expected value of x square would be called the second movement. And similarly, we can get the nth movement as well of the random variable x. Now, I think this will become very intuitive since we know that E of x was computed as summation of x and px. Therefore, expected value of x square will be computed as summation of x square px. Now, once again, going back to our original distribution, this would mean 2 square into 0.2 plus 5 square into 0.3 plus 10 square into 0.5. This will be the expected value of x square, which is computed as, so 4 into 2.8 plus 25 into 0.3, that is 7.5, plus 100 into 0.5 is 50. So 57.5 plus 0.8 will be 58.3. Now, using this expected value of x square, we can easily calculate the variance as 58.3 minus 6.9 square. So this here is expected value of x square, and we are subtracting the square of the expected value of x, which we computed earlier. So this is how we calculate the variance of any random variable, and variance represents the second movement. Variance represents the spread in the random variable. So another way to look at variance, how we basically got to this particular formula here. So there's a small derivation which we can actually look at. So variance of x is nothing but summation of x minus ex square. So what we are doing here is we are actually calculating the expected value of x minus expected value of x whole square. So this is like getting the expected value of this particular expression. Oh, by the way, ex, which was the expected value, since it is the mean of the random variable, it is also represented as mu, and variance of x is represented as sigma square, whereas standard deviation of x would be represented as sigma. So now we know that sigma square is nothing but expected value of the x minus mu whole square. Now this could be written as summation of x minus mu whole square px. So we are just replacing x with x minus mu whole square, since we are finding the expected value of x minus mu whole square. And now this can be written as x square px plus mu square summation of px. So we just brought the mu square out of the summation operator because this is a constant. It is not a function of x, since it is already computed as 6.9. And finally we have 2 mu summation of x px. Now if you note here, the first term here is expected value of x square. The second term would be mu square, because summation of px, this particular term, is equal to 1, because we are just summing up all the probabilities, and we already know sum of all probabilities is 1. And then we have minus 2 mu, and summation of x px is again mu. So this is expected value of x square plus mu square minus 2 mu square will give you minus mu square, which is the required variance formula, which we were mentioning earlier. So this is how we compute the variance of a random variable x. So this is it for this particular session. So here we looked at what is expected value. It is the average value of a random variable, which is computed as the sum product of the random variable value with their corresponding probabilities. Then we looked at how we can simulate values of x for a given probability distribution using a uniformly distributed random variable u in the range 0 to 1. So once we have done that, if we keep doing a lot of trials, we would expect the average value of all these trials x values to come closer to the calculated expected value of 6.9. Then we looked at variance of the random variable, which is nothing but a measure of spread of the random variable, and it is computed as expected value of x square, that is the second movement of x, minus mu square. Mu is nothing but same expected value which we calculated as 6.9 earlier. So this is about it from expected value and variance. Now for each of the distributions which we saw earlier, the 5 discrete distributions, we'll try to find the expected value and variance using these fundamental formulas. So stay tuned.